Right, so the CD4051 has the following truth table, whereby if you send high or low to the channels A, B, C, which is 11, 10 and 9 on the chip, then you get an output or an input depending on on pin 3, whether that is high for out or low for input. So here it is on a breadboard. We have the button on the left which is feeding into pin 3, so that determines high or low. So when I push that, that's going to be a high signal, so that's output. And the 3 buttons on the right hand side which correspond to channels C, B and A, reading from left to right. Alright, so there's the truth table and the chip superimposed over the actual breadboard, and we're just going to firstly light up the pin 3, so that's output, and also that is pin 11, which is channel A or S0 on the table, which gives an output to pin 14. And similarly, mashing pin 10, which is channel B or S1 on the table, gives an output to A2 or pin 15. And then we have our inputs. So if we've got pins 9 and 11 activated, then that is A5 or pin 5, which is input, and all 3 pins 9, 10 and 11 high, and we end up with A7 or pin 4 being input. So the chip works. So now as a voltage divider, with those values coming in and 9 volts fed in, we should be able to get a 3.3 and a 5 volt output. So the next thing to do is to just try that with the buttons. So I'm going to set up the breadboard, same as before really, but this time going out to a voltage divider. Slightly higher voltage coming in because of the losses through the CD4051. So that's the 5 volts, and then that's the other channel giving 3 volts. So yeah, in theory that works. And let's just try it now so you can see it live. So there's your slightly more than 5 volts, so I've got 9.6 coming in, so that's a bit high, and then your 3.2, so that's fine. Now in order to get 9 volts through, we needed to use a transistor. So initially I started with the SS8050 NPN transistor, but you can see with the 9 volts coming in at the top at the collector, that's always on, so it's always giving us 9 volts, which is not good. So I had to swap that out for the 2SA1020 PNP, and you can see with the voltage divider on the collector side, that works fine. So let's have a look at that on a breadboard. We have the LM7805 on the left hand side, converting the 9 volt rail to 5 volts to be fed into the A-Tiny13, which then has the outputs on PB0, 1 and 2 going to channels A, B and C on the CD4051. I've also got the pin PB4 feeding into pin 3 on the CD4051, so that's always output. There's your PNP transistors, which are fed by 1K resistors from the outputs on the CD4051. And here it is. So it's feeding in the 9 volts through those PNP transistors to the voltage divider, which is just flicking over to 5 volts and then 3 volts with a little bit of a rest in between. So that's fine, but then that could have been done just by the A-Tiny13. So just to illustrate that it is a little bit more versatile than that, I set up a second breadboard here, pretty much the same code, but just with some flashing LEDs coming out of some outputs on the CD4051. So in the end, with the voltage divider and the 4 LEDs, that is 6 outputs from the CD4051, 2 still spare, and the A-Tiny13 chugging along fine. So yeah, that's the circuit working, a very versatile chip, and I think we'll see that one again on the blog and on this channel.